Hello everyone, this is lesson 6.3, solve linear systems by elimination. So far you've learned how to solve system of linear equations by graphing them and by the substitution method, but this is the elimination method which you were exposed to when we did quadratic and linear equations, but this is a little bit different. It's easier, I think. So if you're an e-learner today, you're going to be watching this video. If you're in person, we're going to be doing this in class, so you will not have to watch this video. So the idea of elimination is to combine the equations by eliminating one of the variables. So in order to do that, one of the variables has to be the same but opposite sign, so that when you add them, like -3 and +3y, then they cancel out. So the nice thing about this is we're not subtracting the equations, we're adding them. So we need to get them to be the same but opposite coefficients for at least one variable. So let's add up these equations. So -3x minus 9x would become -12x, and then these two would cancel out, so you wouldn't put anything there, and then equals 12 minus 24 is -12. So if you divide by -12, you get +1. So then remember that if you get x equals 1, you have to plug it back into the equation to get the y value. Now, it doesn't matter which equation you choose, but I'm going to choose the easier one, which would be the first equation because the numbers are smaller. So I'll do -3 times 1, which is just -3, minus 3y equals 12, and then add 3 to the 12. So that gives us -3y equals 15, divide by -3, and you get y equals -5. So then our solution would be 1, -5. All right, now notice in these two equations, they were both in standard form, ax plus by equals c. So before starting, if they're not already in standard form, then we want to get them to be in standard form so that the x's and the y's are like stacked on top of each other. So when you combine them, it's easier to do that. All right, so here I see that the x's are the same but opposite signs. So if we were to add these two equations up, then the x's would be eliminated. So then we'll add up the y's, -6y plus 5, or y would be -5y. And then -24 plus 24 is 0. If I divide both sides by -5, I'm still going to get 0. So y is 0. Now, be careful because some students think that if you get 0, then that means no solution. But you do get a solution, y equals. If the y's don't cancel, then that means you have a solution. Okay, then plug 0 back into the equation. I'm going to use this first equation. So I'm going to say -8x, and then the y is 0. So if I divide both sides by -8, I get -3. So -3, 0. So that means if you were to graph these two equations, they would intersect at -3, 0. That's where their intersection point would be. All right. So this one, the reason why the number 3 is a little bit different is because the x's have the same coefficient, but they're not the opposite sign. So in order to make them the opposite sign, we'd have to multiply one of them by negative. We're going to go ahead and multiply the second one by negative because that would just make everything positive. So this would be plus, plus, and plus. So you're just changing the signs. All right, so now the x's will cancel. We get 3y and 5y is 8y. 2 plus 30 is 32. And that makes y equal to 8. And then you plug 4. You plug 4 back in to one of the equations. I'm just going to go ahead and do this one. -5x plus 3 times 4, which would be 12. Subtract 12 from 2. You get -5x is -10. So x is 2. 2, 4 would be that one. Okay, and then 4 is different because neither of the variables have the same but opposite sign. So I am going to have to multiply one of the equations and create an equivalent equation that does have the same but opposite sign. So if you look, to get the x's the same, I would have to multiply both equations by a number. But to get the y's the same, I only have to multiply the top equation by 2. And not -2, just regular 2, because and then that would make positive 4y and negative 4y. So the resulting equation I'm going to write down here. So 12x plus 4y equals 60. So just make sure you multiply everything by 2. Okay, now I'm going to combine the equations. This would make 21x, y's cancel, equals 63, divided by 21, and we get 3. And then plug 3 back in. Now, you can plug it into this equation, but I'm just going to pick one of the original equations because the numbers are smaller. So I'm just going to do this one. So 6 times 3 is 18, plus 2y equals 30. Subtract 18, you get 2y is 6. Sorry, 12. I'm ahead of myself. So y is 6. So 3 comma 6 would be that one. All right, let's see how many more examples do we have. There are quite a few more examples. We won't do all of them. Let's just talk about this first step. So question, which equation are we going to multiply by something in order to cancel out a variable? First equation or the second equation? Or do we not have to multiply anything at all? And second question is, what would you multiply the second equation by? So are we going to multiply this equation by to get it to be the same but opposite sign to one of the variables here? So the answer to that would be 3, because then my x's would be the same but opposite sign of negative 12. So that's going to be negative 12x plus 12y equals 36. Okay, and then proceed to combine your equations and solve for y, and then finish by solving for x. All right, now for this question, the problem is that the x's and y's, you can't just multiply by one thing in order to get them to be the same but opposite sign. So we're going to have to multiply both equations by something. So if I multiply the top equation by 3 and the bottom equation by 2, then the x's will both be negative 6. So I'm going to write the new equations over here, negative 6x minus 21y equals negative 39. And then this would be positive 6x plus 12y equals 30. Okay, then what would the resulting equation look like? Okay, that would, x's cancel, so you don't get any x's. Combine these to be negative 9y equals negative 9, so y is positive 1, and plug it back in to get x. I'm not going to show that step for the sake of time. All right, and then for this one, so what can we multiply both equations by in order to get one of the variables to be the same but opposite sign? So I would think that multiplying by both equations to get the x's to cancel would be the best option here, because 9 and 7, I guess we could multiply by 7 and negative 9, but let's just do the x's. So think about like common multiples. So if I multiply this equation by 3, and now this equation, if I multiply by 4, I would get the same coefficient, negative 12, but I want it to be the opposite sign, so I would multiply by negative 4. So this would be negative 12x plus 27y equals negative 33. And then this equation would be 12x minus 28y equals positive 36. So combine your equations and you get negative y equals 3, so y is equal to negative 3. And once again, plug negative 3 back into the equation to get the x. All right, and then there's one more here we'll talk about. So for this one, I'm going to do something different. Yes, you can multiply this top equation by 2 and the bottom equation by negative 3 and get the x's to cancel. But let's say we wanted to cancel out the y's just to change it up. So I would do the top equation by 9 and the bottom equation by negative 2. So then the new equations would look like 27x plus 18y equals, now the problem is I might need my calculator to figure out 9 times 18. What's 9 times 18? Negative 162. And then this equation gives me negative 4x minus 18y equals positive 24. So that makes 23x equals, now I have to do minus 24, so that makes negative 138. And I'm hoping 138 is divisible by 23. And it is. It's 6. X equals negative 6. And then plug it back in. So if we did 2 times negative 6 plus 9y equals negative 12 and solve for y, we get negative 12. Actually here I think the negative 12s would cancel, so you get 9y equals 0, so y is 0. So negative 6, 0 would be our solution for this question. All right, so that is the end of this lesson. And then tomorrow you're going to do the 6.3 Elastic. I'll probably open it earlier in case people want to do it earlier and have Friday off. Or I'm going to be posting like an optional A review on Friday in case you wanted to have time to do that. Or if you just want to go ahead and do the Elastic assignment now while after watching the video, it's still fresh in your head. But other than that, that's all, and I hope you guys have a great spring break.